Hello class, welcome to Pre-Algebra Lesson 2-4, which is all about evaluating square roots and cube roots. By the end of this lesson, you should be able to find square roots and cube roots of rational numbers. So let's get started. First things first, square roots. These numbers are usually going to have something to do with area in this lesson, okay? So if we were asked to deal with area, you are going to do a square root, okay? And just a reminder, a square, remember, if you think of like the shape, I wonder, do I have a shape pen? Let's see what happens if I do that. It kind of worked. Let me try. Alright, there, you have a little square. So a square is where the four sides are all the same. And excuse me. So if this is 1, that means this side is 1. And in order to find the area, you would do 1 times 1, which is 1. And to work backwards, let's say I gave you the area and I wanted the side length, you would do the square root of that number. The square root of 1 is 1. And let's change it to a different number. So let's say that the side length was 2. That means the area of the square would be 4. And if I were given the area of the square to begin with and asked to solve for the side length, I would do the square root of 4. And you can see this table or this image that I have here is going to be a really helpful tool because it has those square roots listed out for you all the way through the square root of 625, which is 25. Alright, so this page is going to be really, really helpful. If I were you, and memorizing isn't something that takes a ton of effort for you, I would take the time to memorize at least 1 through 15, okay? 1 through 15 would be really helpful, but knowing some of these other ones also helpful. If you can't memorize that, don't stress, it's okay. Things might just take you a little bit longer, and that is just fine. Okay, so if you see a problem today that has to do with area, we're going to work with squares. But if you have a problem today that talks about the volume, we are going to be working with something called the cube root. And the cube root is where you take a number and you multiply it together 3 times. So let's say I have 2 cubed, that's what it's called when it's raised to the 3rd power. 2 cubed is a shortcut to saying 2 times 2 times 2. And if I were to simplify that, I could say 2 times 2, well that's 4, and then I still have that third 2 to deal with, so 4 times 2 would be 8. So you'll see 2 to the 3rd power is 8. And likewise, if you are given a problem where you already have the information where it's written in the cube root, it'll look like this and it'll tell you what it equals. But just know that these numbers work backwards. So if I were to start at the 8, I know that the cube root of 8 would be 2. Okay, or the cube root of 216 is 6. So it's important to know that it kind of goes both ways. All right. The other thing you should note is on this right hand side of our page where we have those cube roots, notice that it's that square root symbol but with a little 3. That's telling you that we're dealing with a cube root instead of a square root. You might be wondering, why doesn't a square root, oops, I don't know where that came from, why doesn't a square root have a 2 if a cube root has a 3? And honestly, a square root can be written like this. So the stuff that we were working with on that last page, it can be written like this. It's the same thing as just a traditional square root. Okay? So with a 2 or without a number at all is a square root. Otherwise, you have to have a number listed outside of the root to determine which root you are looking for. And yes, there are more roots than just a square root and cube root, but you'll learn about those in other math classes, okay? Let's jump into our first problem today. Evaluate cube roots to solve problems. So we have Leah is building a birdhouse for purple martins, and these birds are ones that prefer cube-shaped birdhouses. What are the dimensions of each square piece of wood Leah needs in order to build the 216 cubic inch birdhouse? All right, so I see cubic inch. I don't see the word necessarily that says volume, but cubic inch, seeing cubic with a measurement, that's going to mean that we're dealing with volume. And that also means the cube root, right? The cube root of 216. So what I'm going to do is I'm actually going to go back a page and I'm going to look, where does that 216 appear? I see that with my table that has all of those cube roots, it doesn't go all the way up to 216. So I'm going to go back to the left side of the page and I'm going to look for the number 216. I see that the number 216 is connected to a 6. So that tells me that the dimensions for the birdhouse would be 6 inches, because we're going to label our answers 6 inches. And that would be the length of each of the sides, okay, and the heights. And when we are looking at this birdhouse, you can see, we're talking about a cube. And maybe you remember from past math classes, in order to find the volume of something, we would often do like length times width times height. That is what we are doing here. It's just all of those numbers are the same. So we would say 6 to the third in this case, and that's where the 216 cubic inches come in. Okay, so we've found the number that we need. Now we need to write our answer. What are the dimensions of each square piece of wood? Okay, so each of these squares, what are the dimensions? And if we are looking at this side is 6 inches, this side is 6 inches. So the dimensions would be 6 inches by 6 inches. Because it's just talking about a single side at a time, and all of them are 6 inches by 6 inches. So that's how I would answer this question. All right, let's move on to the next one. We have a cube-shaped sculpture has a volume of 64 cubic feet. What is the length of each edge of the cube? If you need to, excuse me, go back in the video to take a look and find that 64, go for it. Good luck. All right, hopefully you figured out the length of each edge of the cube would be 4 feet, because 4 times 4 times 4 is 64, or maybe you went the other way and you said the cube root of 64 is 4. Either way, you found the number 4, hopefully. If you have questions about that, please be sure to reach out for some help. I'm happy to help you. Let's move on to example 2. Example 2, excuse me. All right, now you can see I have a lot of square roots, or 2 square roots and 2 cube roots. So I'm going to use that same information that we've been using. I'm looking for the cube root of 64. So if I go back to that page, I see my 64 that lines up with 4. So the cube root of 64 is going to be 4. The square root of 100, I just said it, the square root of 100 is 10. Usually a lot of students feel pretty comfortable with that one. If that is not you, don't worry. More practice with it should make you more comfortable. And then we have the square root of 49. You can notice I even practiced writing the 2 there for you to see. You will very rarely see that 2 written outside the square root. But what's the square root of 49? What times itself gives us 49? That would be 7. Okay, and then I'm looking for the cube root of 8. So what times itself gives us 8? So if I go back here, I can see on my cube root side, I have that cube root of 8 equals 2. And if I were to go on the other half of the page, I would see 2 to the third power, or 2 cubed equals 8. So you can see either way, I end up at that 2 is related to that 8, right? Okay, so these would be my answers for evaluating the perfect squares and the perfect cubes. Let's move on to our last example for today. We have Sean cuts one sheet of colorful poster paper to cover the bulletin board exactly. You can see he has this bulletin board over in his locker. It says the area equals 144 inches squared. We want to know what are the dimensions of the poster paper. So we are talking area, right? Because we have A equals. So area means that I'm going to work with squares. And I want to know what is the square root of 144. The square root of 144 is, feel free to use that table on that second page. Hopefully you ended up with 12. Okay, so the square root of 144 is 12. That means that our answer would be 12 inches by 12 inches. So whenever you're asked for dimensions, you are going to have to list more than one number. So since we're talking about a square, we're talking about area, I have 2 numbers listed, and they're going to be the same exact thing right now. All right, we have Emily wants to buy a tablecloth to cover a square card table. She knows the tabletop has an area of 9 square feet. What are the minimum dimensions of the tablecloth Emily needs? Good luck. All right, for this problem, hopefully you figured out, since we're talking about area, we're going to do a square, and the square root of 9 is 3. So the minimum dimensions of the tablecloth would be 3 feet by 3 feet. If you have questions about that problem or anything else from this lesson, please don't hesitate to ask for some help. I am happy to help you, and I hope you have a great day.